Oh, I asked you to come back, and you did. Okay, so let's look at what a function is. So suppose I have a relation. Whoops, I want to be on pen mode, thank you. Suppose I have a relation, but I put a restriction on it. To every element of the domain, there is exactly one element of the range that's associated. Okay? And usually these will be numbers to numbers. But remember, in the previous discussion for relations, you could have one input corresponding to many outputs. In the example that I used verbally, buildings to people who live in them, if a building has many people living in it, well then one building can be related to many different people. But that wouldn't be a function. A function says, to each input you associate exactly one output. Okay? The inputs are called the domain, the outputs are called the range, or the image or the value. Notice there might be some things in the set Y that aren't mapped to, okay? So that's okay. The range is everything you get out. The set Y might include some other stuff, and we'll see some examples of that in a minute. The domain, however, has to be stuff you can plug in. Okay. So we're going to do a couple examples of, can I determine whether something is a relation or an actual function? Okay. So take a look at this right here. The things we plug in are food items, and the things we get out are prices. This is definitely a relation because to each food item, I associate some prices. Is it a function? It is. Okay. To each input, there is one associated output. It's okay that the output, $2.50, has multiple corresponding inputs. That's fine. Okay. What would be bad, what would make this not a function, is if one input was sent to multiple outputs. For example, if I had this arrow as well, then it wouldn't be a function. I'd say, what's the price of a shrimp taco? Gosh, it's either $2.50 or $4. I don't know. There were multiple outputs. I don't know how to decide what. That's not a function. Okay, but as drawn without the red arrow, it definitely is a function. Each input gives me one output. Okay. How about this? Is this a function? It definitely is. Each input has one output. They're actually lined up one-to-one. That's great. Is this a function? Well, the domain is people, and the output, the range, is where they were admitted to college. Congratulations, everybody. You did very well for yourselves. This is not a function, okay, because one of the inputs, specifically Aaron, overachiever, was admitted to both Princeton and Duke. Okay. So let's not shame Aaron. She did very well. It's quite an accomplishment, but not a function because to each input there could have been multiple outputs. Okay, how about this? Now we don't have a nice picture. Is this a function? So first let's look at what the domain is. The domain, remember, is the stuff that is on the first coordinate, 1, 3, 5, 9, and the corresponding range, 5, 9, 1, 2, which the book has simply written in increasing order. It is a function, and we can do this, we can see this nicely by drawing it. 1 gets sent to 5, 3 gets sent to 9, 5 gets sent to 1, 9 gets sent to 2, and every input has a unique thing that it's sent to. This is a function. Okay. How about this? Okay. Well, 2 gets sent to 6, 5 gets sent to 5, 7 gets sent to 5, and 1 gets sent to 15. So is this a function? Yes. Okay. How about this one over here? -5 gets sent to 1. Whoops, back to pen mode. -5 gets sent to 1. -2 gets sent to 3. 2 gets sent to -2. And -5 also has to get sent to -3. Notice that I have this pair and this one. -5 is being sent to two different places, so it's not a function. Okay. How about this? Y is 3x plus 7. Is y a function of x? So what it does is it says if you input x, what you do is multiply by 3 and add 7, and then you output y, which is 3x plus 7. Is it ever possible to get multiple outputs? No. Anytime you input a number, 3x plus 7 is uniquely defined. There's only one thing you're ever going to get out. So this is a function. For example, if you plug in x equals 1, you get out 10. If you plug in x equals negative 3, you get out negative 2. This is a graph. If you graph this, it's a line. Its slope is 3. Its intercept is 7. Okay? And if you need to review slopes and intercepts of graphs, go back to some of the Chapter 1 videos. Okay? This is a linear function. Any graph that has a slope like this is a line. Okay. Here's something a little more convoluted. 6x plus 3y squared equals 2. If I input an x, do I get out a unique y? So what we want to do is we need to solve for y. So the first thing we do is subtract the 6x over, divide by 3, but then notice I can't just take a square root. You have to take a plus or minus square root. So here's our solving for y, plus or minus root 2/3 minus 2x. But notice if x is less than 1/3, I actually get 2 outputs. For example, just let x equal 0. You get plus or minus root 2/3. If x is 0, that's the easiest thing to consider. I can kind of ignore that. Then y is plus or minus 2/3, which is 2 different numbers. So one input gave us 2 outputs. So this is not a function. It's an equation, that's certainly true, but it's not a function. One input of x could give me more than one output of y. Okay. So I'll stop here. Just again, I like to emphasize breaking this up into small little topics. So come on back for function notation.